Okay, we have here today an interesting sum. We've got the sum from n equals 1 to infinity, 1 over n minus 1 over n plus 1. And I've been doing a lot of problems a lot like this. I mean, I know I did like 4n plus 1 here, 3n plus 1, 2n plus 1. It's all very similar. I've kind of been like cycling through a lot of the same methods. I just like to overkill it, particularly the Digamma function. I just feel like doing a lot of problems with Digamma function, even though you'll notice we don't need it here. Because if you just started to write out terms, you plug in 1, you're going to have 1 over 1 minus 1 half. Then you're going to have a plus 1 half minus 1/3. And what you're going to notice is things are just going to start canceling out. And so this is actually a telescoping series, and you can just kind of write out terms, cancel things out, and very quickly get to a solution. But that's pretty boring, so let's not look at that. I'm just going to make that go away. And I want to look at our Digamma function definition over here, just noticing that our series definition, this piece is really similar to what we have here. The only thing different from this to this is our input on it. The input in the formula for the Digamma function, the z value, is right here. And so here, our z value is going to be just equal to 1. So just by rearranging this formula a little bit, if I add this, which is the Euler-Mascheroni constant, something like, this is somewhere around 0.577. If I just add this on both sides, this is going to cancel. And then we've got a way to express the series in terms of the Digamma function. So rewriting our problem this way, where z is going to be 1, what we're left with is just Digamma of 1 plus 1, or 2, plus Euler-Mascheroni constant. And so all I want to do now is just let's reduce this, try to get this to some kind of numeric value. For Digamma of 2, what we can do on that is we have a recursion formula. For Digamma of z plus 1, we can write this as Digamma of z plus 1 over z. So using this for Digamma of 2, writing it this way, we can subtract 1 and write it as Digamma of 1 plus 1 over this, which is just going to be 1 plus Euler-Mascheroni constant. But what you can do on this so that you're not just reducing endlessly is remember one value. And for Digamma of 1, this is going to be the same thing as minus Euler-Mascheroni constant. So I'm just going to plug that back in. Minus the constant plus 1 plus the constant. These values are going to cancel out, and we're left with our solution for this of just 1. And if I would have kept up the telescoping series just a little bit longer, you would have seen everything cancels out, and the first term was 1. This value right here was 1, and so the solution, again, is just 1. Okay, there you go. Pretty easy example with the Digamma function. Thanks everyone for watching. Have a good day.